Math lovers, let's talk about notes number 36. Quick introduction to polar coordinates and graphing here in chapter 2. So we want to think about our Cartesian coordinate system. Every single time you're going to work with these, horizontal is the x, vertical is the y. And you're going to name your quadrant by Roman numerals, starting with quadrant 1 and then working in the counterclockwise direction. Okay, let's look at this first example they have for us. It says, use the table to write the ordered pairs and express the relationship between each category and the amount spent on it. So we're talking here about the category being our X and the amount spent as being our Y. So they want to talk first about housing. So you just want to write that as an ordered pair. So I would say housing, comma, and then you look over to how much housing is, and that is 19,884. I'm going to not put in a I'm not going to put in a comma here. I don't want you to think it's an ordered triple. And the next one is entertainment. So let's look over here at our entertainment value, which is down here. So I'll write the ordered pair entertainment, comma, 3203. Okay, I'm going to leave the dollar sign in there so my reader knows exactly what I'm talking about. Not quite sure how your textbook's going to want you to write that answer. We will talk about the rectangular coordinate system. I know you might think, well, what is it if it's not rectangular? There are other coordinate systems we'll study later on. We're going to talk just about the Cartesian coordinate system, which was developed by Descartes. And that's where we get the name Cartesian coordinate system. We're always going to use our XY plane. Okay, it's divided into 4 quadrants. All right, let's jump right into a formula I know you know and love, and that is the distance formula. The distance formula is going to be the difference in the x values squared and the difference of the y values squared. We sum them and take the square root. I think you're kind of familiar with this. We'll jump right into an example here for you. So I have 2 ordered pairs, P and Q, and they would like you to find the distance between P and Q. So let's start off with, let's start off with the square root. I have labeled my x1, y1, my x2, y2. We're going to go ahead and just put that right into the formula. So I'll start with my difference of my x's. So that would be 3 minus -8, and I'll square it, plus the difference of the y's, so -2 minus 4 squared. So I've got positive 3 minus 8, which is 11. So I have the square root of 11 squared plus -6 squared. Now we're going to think about that -6 squared. Okay, the -6 squared is in parentheses, so it's going to end up being positive. So I have 121, the square root, of 121 plus 36, which is going to give me the square root of 157. We're going to leave our answer as the square root of 157. Okay, we're not going to change it. All right. Now, what's fun about the distance formula is you can use it to help you determine if you actually do have, say, a right triangle. Okay, so let's take a look at the next one. We've got determine. Here we go. Applying. Determine whether the points M, N, and Q are the vertices of a right triangle. Now, as soon as you see right triangle, I think you're thinking about the Pythagorean theorem, right? Remember, Pythagorean theorem is a squared plus b squared equals our c squared value, okay? Let's see if I can get this pen to be a little bit more narrow, okay? So the first thing I'm going to do is find the points M and N. So here are the coordinates that I'm going to work with. I'm going to work with those 2, okay? So I want the difference of the x's and the difference of the y's. So that's going to be 12 minus -2. And I'm going to square that. And then I'm going to take the difference of the y's going in the same order, 3 minus 5. And I'm going to square those. So let's see, 12 minus 2 is 14. So I've got 14 squared, which would be 196, plus 3 minus 5. Let's see, 3 minus 5 is 2, -2, squared it. That's positive 4. So I've got the square root of 200. Okay, let's go and let's try another side. Let's see if I can do this in purple. Make it a little more narrow. Okay. So the next one is M and Q. So I'm going to do M and Q. Okay. So I'm just highlighting them. So that's what I'm thinking. I'm going to take the difference of the X values. So the square root of the difference of the X values. So that's going to be 10 minus negative 2 squared. And then I'm going to do the difference of the Y's, which will be negative 11 minus 5, and I'm going to square them. So let's go ahead and do our calculations here. We've got positive 12 squared, that's 144. So 144. And then negative 11 minus 5 would be negative 16 squared. That's going to be 256. So I add those two together and I get the square root of 400. Okay. So even before I go any further, I know that square root of 400 is going to be my longer side since it's so much bigger than the two sides that I'm working with. All right. Let's go ahead and let's switch colors here. Let's see if I can make this a little bit. Let's make the red. So now I'm going to work with N and Q. So I'm going to work with N and Q. Okay. So highlight those two. So we're going to take the square root of, I'm going to take the difference of the x's. So that would be 10 minus 12 squared plus the difference of the y's. That would be negative 11. I started with this coordinate, so I'm going to go negative 11 minus 3, and I'll square that. So let's see. This would first give me negative 2 squared, which would be 4. So the square root of 4 plus negative 14 squared, again, keeping it positive, that's 196. So that gives me a square root of 200. Before I go any further, I can tell these two sides are equal. That gives me what's called an equilateral, not equilateral, excuse me, that gives me an isosceles triangle. Oh, isosceles. Okay, now my question here is determine whether it is a right triangle. So we need to decide that. If it is a right triangle, remember we're going to use, this different color here, purple. Okay. So I'm going to say, is it leg squared plus leg squared? Does that equal my hypotenuse squared? All right. If it is a right triangle, this is going to be a true sentence. So I'm going to go ahead and plug those values that I had up there. My two legs are the square root of 200 and square root of 200. So I have the square root of 200 squared plus the other leg. Here's one leg. Here's the other leg. The square root of 200 squared. Does that equal my square root of 400 squared? Well, the square root, something squared of a square root. So that's 200 plus 200. Does that equal 400? Yes, that is true. Therefore, it is a right triangle. Okay. So we have just proved that this does give me a right triangle. The last formula to go through with you today is what's called the midpoint theorem. And I'm sure you've done this before. The midpoint theorem, you're going to find the average of the x's and the average of the y's to give you the midpoint. So if you get any two ordered pairs, you're just going to add up the x's, add up the y's, divide them by 2. And we just use the word average to mean the midpoint. Have fun with your problem set.